All right, so today we're going to look at lesson 49. We're going to look at circuit analysis part 1. Hopefully you'll understand circuit analysis after this lesson. We looked at Kirchhoff's current law and Kirchhoff's voltage law on lesson 47, I believe, to find the currents and the voltages in a circuit that contains passive elements such as resistors and sources of electromotive forces such as voltage sources. So we looked at that in lesson 47. Whenever we do this, we must remember that the voltage across an active element is fixed and that the voltage across passive elements is determined by the currents that flow through the passive elements. So if you look at the picture, suppose we want to find the current that flows in the circuit and the voltages across resistors R sub 1 and R sub 2. The voltage that's across the voltage source is 15 volts, because that's what it shows, the 15V, with the top at a higher potential than the bottom, because the top is at the positive. And so this is the way we hook up this circuit in the lab. We would set the voltage of the voltage source at 15 volts, so that voltage doesn't change, or so that it's known and it doesn't change. And then the ground connector at C would not be affected for the operation of the circuit. So we connect point C to the ground, so we won't get shocked if we touch point C. And so then they have a 3-step procedure for finding the current. Step 1, you name the current direction. There's only one current, and we have two choices, either clockwise or counterclockwise. And we choose to let it be a clockwise current. And as you can see, they named the I, they made it go clockwise. Okay, so we're going clockwise for this current. The second step is to name the voltages and place a plus sign and a minus sign on each resistor so that the current I enters the resistor at a plus sign. And it says the correct placement of the signs is crucial. So if we're going this direction, positive and then negative, positive and then negative. It has to enter from the positive side for the resistor. And then it says for step 3, you draw a starting flag between any two circuit elements. So you're just going to start at that flag. And it can be anywhere that you want. And you don't really have to make a flag. But you can, if you want to make a starting flag, you can just pick a point and make that your starting point. Okay? So it says that the voltage across this one is I R sub 1. And then the voltage across this one is I R sub 2. Because remember your formula V equals I R. And we know that all of them in the circuit have to equal 0. So if we go counterclockwise from the flag, we're going to have negative I R sub 2. And then we're going to have negative I R sub 1. And then we're going to have a positive 15. And those are the only three we have, so those all have to add up to 0. If you look, we know that R sub 1 is 2, and R sub 1 is 2, and then R sub 2 is 3. So we have negative I 2, negative I 3, plus 15 equals 0. And so these two would be negative 5I plus 15 equals 0. So 5I equals 15. So your I would be 3. So the amp on this one is 3. So 3 times 2, this voltage here would be 6 volts. And then 3 times 3, this volts here would be 9 volts. Okay, so that's how that would work. So we're going to look at an example. We actually only have one example on this one. They give us a picture. We're going to let the current, we need it to be going through the positive V first. So we're going to let it go this direction. It's going to be going counterclockwise. And then we need to put signs on the R sub 2 and the R sub 1. So it's always going to the positive first. So this is the positive side, and that's the negative side. This is the positive, and that's the negative. And then we need to start somewhere. So we are going to put our starting flag down here. There's my starting flag. All right, so let's go. As we go around, we have R sub 2 is positive, so I R sub 2, and then plus, because we hit another plus, I R sub 1, and then, whoops, not equals. And then if we keep going, we get a positive 30, so plus 30. And all of those have to be 0. We know that R sub 1 is 10 and R sub 2 is 5. So I times 5 plus I times 10 plus 30 equals 0. So that would be 15I plus 30 equals 0. So 15I equals negative 30. And so I would equal negative 2. So that doesn't mean that we chose the wrong direction for the current. It just means that the value of the counterclockwise current is negative 2. So your current can be negative or positive, and your voltages can be negative or positive. So the voltage here is going to be R1 is 10, so 10 times negative 2, negative 20. And the voltage here is going to be negative 2 times 5, so negative 10. And then we're looking the voltage from C to A. So if we're going from C to A, the voltage that we go across is a negative 10. And so V sub CA would be negative 10 volts. Okay, so that's how that works. So your homework is numbers 1 through 20, and then make sure to look at the curveball questions. Do those tonight so we can go over any questions you have tomorrow.